In the previous video, you've seen how we may use steady-state probabilities to make decisions, including when playing Monopoly. So next time you're playing Monopoly, probably you should copy the table from the previous video to look at the steady-state probabilities of each square. Okay, so now let's talk about another thing which is called mean first passage times. Okay, so before we define what is mean first passage time, let me draw your attention first to the keyword ergodic. Same as before, mean first passage time exists only when the chain is ergodic. So that's why we learn to identify ergodic chain, because steady-state probabilities, mean first passage time, they only exist when the chain is ergodic. Mij is defined as the expected number of transitions before we first reach state J, given that currently we are in state I. So we are in state I, and then mean first passage time is how many steps later in the average we will reach J for the first time. So that is why it is called mean first passage time. So when we want to compute the number of steps that we can reach J, given that we are now in state I, we may break this down into two conditions. The first condition is that we may reach J in one step, right? You are now in state I, and then in the next step you are in state J. So you just need one step. What is the probability that this one step happens? Pij, right? Because Pij in the transition probability is one step probability of transitioning from I to J. But you may also need more than one step, right? Because from I, you may go to any other state, and then sometime, someday, you will reach J. So that's the second part. So the second part says that from I, you go to K, in which K is not J. But then from K, how many steps will you reach J? Because remember that our purpose here is J. Okay, so if you go to K and then in mkj steps later, you will reach J, right? So if you look at this part, why it is 1 plus mkj, because one step here is that from I to K. So in one step, you go from I to K, and then in mkj steps, you will go from K to J. Okay, so to summarize, when you want to say how many steps from I to J, you may break it down into one step. So from I to J directly, or 1 plus mkj step. One step here is from I to K, and then from K to J requires mkj steps. Now, if we multiply this, let me change the color. So if you multiply this sigma pik with 1, you will get, and then sum it up with the previous term, you will get the relation that Pij plus the sum of Pik for all k that is not j must equal 1. Right? This makes sense because if you are now at state I, the probability of going from state I to j plus the probability from I to any other state that is available must be equal 1, because you must go somewhere in the next step. You may stay in I itself, you may go to J, you may go to K, you may go to anywhere, but the sum of probability must be 1. Okay, so that's why we may replace this to look like this. We replace the first two terms, Pij times 1 plus sigma Pik to become 1, and the remaining is sigma Pik times mkj. So this is that multiplication. We may solve all these equations, and then obtain all the mean first passage time. The special case is that when we want to solve MII, so the expected number of reaching the state I again, given that now we are in state I, it may be solved quite simply using 1 over pi I. Okay, so to summarize, when you want to obtain mean first passage time, you may solve all these equations that looks like this for ij, that is j different to I, and then you may use these equations if I is still the same MII. So you may use the last equation. So in the color example, given the transition probability matrix, and then given that we have computed the steady state probabilities, we may compute all the mean first passage times. So for M11 and M22, we may use the formula 1 over pi. So the interpretation here is that, for example, M11 equals 1/2. It means that if a person purchases cola 1 at the moment, in the average 1.5 purchases later, he or she will purchase cola 1 again. Now for the other mean first passage time, we need to use the first formula. For example, M12. So M12, 1 is J, 1 is I, and then 2 is J, equals 1 plus the sigma of PIK MKJ. But K must not equal J. Okay, so our J is 2, and then this is our I. So you need to list all the other states that is not J. In this case, because we only have two states, the only state that is not state 2 is state 1. So here you have P11 times M12. You need to be very careful because here you need to state all the possible states K, which is not J. If you have, let's say, 10 states, you will have a much longer equation because you have a lot of states K, which is not J. Let's take a look at another example, M21. So 2 here is our I, and then 1 here is our J. Same as before, you need to list all the K that is not J. If you have 3 states, it means that these equations will have P23 times M31. Okay, so you need to follow this equation very carefully, and then notice that the sum says you need to do this for all K, which is K is not equal to J. Now that you have all these equations for Mij, you may solve this to obtain M12 equals 10 and M21 equals 5. The interpretation of this is that, for example, if a person now drinks cola 2, in the average, he or she will buy cola 1 after 5 purchases. So average is the key word. Now here are some questions to check your understanding. Mean first passage time is defined as the expected number of transitions before we reach state J, given now we are at state I. So this is the definition that we've seen earlier. The statement is that, therefore, Mij must be an integer. Is it true or false? I will give you the answer after the pause on the video. The answer is false. Expected number means average, which may be non-integer, right? Because average can be any real number. In the color example, we have M11 equals 1.5, and that is okay because it's average, not something that must be an integer. The second question, given that M12 equals 10 and M21 equals 5, the statement is that if a person now drinks Cola 1, 10 purchases later, the person will drink Cola 2. Is this interpretation true or false? The answer is false, because in reality, if you're looking at a specific person at a particular time, and then now he or she is drinking Cola 1, you cannot say that for sure he or she will drink Cola 2 in 10 purchases later. Maybe he or she will drink a Cola 2 in 3 purchases later, maybe 13, maybe 15, maybe 20, maybe 8. So you cannot say that exactly will drink Cola 2 in 10 purchases later. What you can say is that after you observe that person's purchases in a lot of number or a lot of purchases, you can say that in average, 10 purchases after drinking Cola 1, he or she will drink Cola 2. So only about the average. You cannot say exactly this time he's drinking Cola 2 and then in the next 10 purchases he must be drinking Cola 1. So that's the end of this video, and then in the next one we are going to talk about another chain that is not ergodic, which is called absorbing chain. So see you on the next one, and thank you.